Our method for solving problems like this one so far has been to say that because of the parallel lines, angle A and angle CBD are corresponding angles and therefore congruent. Also that angle E and angle CDB, also being corresponding angles, are congruent. Therefore, the little triangle up the top, triangle CBD, is similar to triangle CAE, the big triangle on the outside, using the angle-angle triangle similarity postulate. Since those two parts are similar, we can form ratios of corresponding sides. In this case, the left side of the small triangle over the left side of the big triangle will equal the right side of the small triangle over the right side of the big triangle. The left side of the big triangle, in this case, will be 6 plus 3, which is 9. And the right side of the big triangle will be 4 plus x. To solve this, we'll then form a proportion and cross multiply. The solution is shown on the next slide. You might try to pause for a second and see if you can do it yourself. So as you can see, we form the proportion. We cross multiply, remembering to distribute the 6 not only to the 4 but also to the x. Subtract 24 from both sides to get 6x equals 12, and then finally x equals 2. Shown on the next page is the same picture for the third time, but this time with a little less information. So because the line BD was parallel to a side of the triangle, AE, and intersected the other two sides, it divided those other two sides into segments that are proportional to each other. Notice that CB, 6, divided by BA, 3, equals CD, which is 4, divided by DE, which is 2. You could check that quickly by doing a cross product. 12 equals 12. We say that the segments CA and CE were divided proportionally by the parallel line BD. And we get the theorem that shows up on the next page, which is called the triangle proportionality theorem. So we have the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, as in our picture, BD intersects CA and CE in two distinct points, B and D, it separates those sides into segments of proportional length. In our picture, BA over CB, those would be the two segments on the left side, equal DE over CD, the two segments along the right side. So it provides a quicker way of getting answers to problems like we had in our last problem. For example, if we were doing that last problem now, we'd have a triangle marked with the 6 and the 3, the 5 and the x. Oops, sorry, the 4 and the x. So let me change that back to 4. And we would have that one side is parallel to another side of the triangle. So, according to our new theorem, 6 over 3 equals 4 over x. That would give us 6x equals 12, and the same answer as we got last time, but a lot quicker, x equals 2. The next video in the series on Moodle gives you more examples of problems like these.